All right, we're getting up there. 27 people have joined, so I say we get started. So, good morning, everyone. My name is Fanny Christensen. I'm with Kittleson and Associates, supporting FDOT with this Basic Traffic Safety Academy. And today we are going to teach you all about Module 8, and that is lane departure safety. This session is being recorded, just as a courtesy reminder. And if you have any questions as we go through, there will be some stops throughout the training where we can take some of those questions. And if you want to post them in the chat as we go, you can also do that. We'll have some folks monitoring those questions, and we'll bring those up when we get to the question points. So what is the Academy? Why are you all here today? So the Academy is designed as an interactive experience to give anyone the ability to successfully determine and solve safety issues on our roadways. And here, kind of breaking down the idea of the Academy a little bit more. So what we are planning to do and how the Academy is structured is we will start off by discussing exactly what it is that we are facing. And then we'll discuss one of the most critical parts of designing for safety, which is the data, and understand how the data works, where to find it, and how to use it. And then we'll take a deep dive into one of Florida's top 3 problems, and then we'll also learn how to solve them and finally work to apply these to real projects. So today we're going to discuss the different ways of addressing lane departure safety, and there can be various techniques that can be used and a lot of different philosophies behind this issue. So this is where you are today with lane departure. And our goal is to understand how significant lane departure crashes are to the Strategic Highway Safety Plan, understand what a lane departure crash is, and understand the recommended countermeasures for lane departure crashes. And those 3 areas are to keep drivers in the lane, help with recovery, and reduce severities. So why are we here today? And really the key message here is one life lost is one too many. On Florida roads, on each day, we have 8 fatalities and 49 serious injury crashes. To put that into perspective, there are 45 people in this meeting right here. So it would be this entire people who are looking at this training would have a serious injury crashes, or almost 5 times as many of us will die just on every day on Florida roadways. So safety starts with us. We design it, people will travel on the roads, and we can anticipate behavior and consequences. And that way we can try to be proactive and how to retrofit roadways to influence safer behaviors. And today we're going to talk about how we can do that in regards to lane departure crashes. And really, safety does not happen by accident. People make mistakes, but those mistakes can be helped to minimized. So the state has adopted Target Zero, and the intent here is to hit zero fatal and serious injury on our roadways. And this effort has a couple of different names. You might have heard about Vision Zero, Towards Zero Deaths, Road to Zero Coalition, but we're going to talk about it as Target Zero, which is FDOT's initiative. And many names, but they all share the same goals, which is zero. And this goal might be ambitious, and it might be a lot of different opinions on how to approach this goal. And there will have to be some give and take to reach this goal. And will it be stress-free? Probably not. Will it go as planned? Probably not, but we will make progress to reach Target Zero. So first off, we're going to talk about the Federal Highway Administration's roadway departure definition and national statistics. So how do they define roadway departure? It's a crash which occurs after a vehicle crosses an edge line or a center line or otherwise leaves the traveled way. And lane departure crashes can have severe severities and catastrophic results from these crashes. So roadway departure or lane departure, the key takeaway here is that rural roadway departures account for a third of all traffic fatalities. This data, I do want to say it's 2014 to 2016 annual averages from FARS. And half of all departure crashes occur on state roads. All roads are affected, but that's a big percentage right there. So what does that actually mean? That means that 30 people will die every day on rural roadways in our country. And that is about as many people that are in this watching the Safety Academy today. So the Federal Highway Administration released an initiative called Focusing on Reducing Rural Roadway Departures, or Forward, as we're trying to get it to be pronounced. And the mission here is to reduce the potential for serious injury and fatal roadway departure crashes on all public rural roads by increasing the systemic deployment of proven countermeasures. And Forward Initiative has 4 pillars and initiatives, and those are proven countermeasures, systemic approach, safety action plans, and focus on all public roads. So let's look into some of those roadway departure causes. And there's a lot of different things that might cause a lane departure crash. It can be due to the roadway condition. You have wet roadways, icy roadways, or something in the vehicle that malfunctions, something with the tires or with the steering, or someone is trying to avoid a collision, or they overcorrect, and which causes them to leave the roadway, or driver error, such as driving while sleepy or distracted or under the influence. And the truth is that the driver is the weakest link in the system, so we must design around human needs. And looking at those numbers and what they really mean, 93% of lane departure crashes are caused by driver error, followed by roadway crashes at 34% and vehicle malfunctions at 13%. But that's driver error is a huge part of what causes lane departure crashes in our country. Some things are a visual trap. Like you can see here, roads can be deceiving. This looks like a straight road, but actually curves just up ahead. So how do we design this to make sure that people can travel safely and make the correct decision? When considering the most harmful events in road departure fatalities, there are 3 crash types that make up over 70% of those crashes. These are head-on collision, rollovers, and collision with trees, which are the primary emphasis of the strategic plan. The secondary emphasis area are focusing on reducing crashes with other fixed objects, including signs, poles, signals, and barriers, as well as crashes involving roadside ditches and embankments. And then, of course, we have horizontal curves. So curb crashes are a national emphasis area. And here you can see the breakdown of those 3 different causes: rollover crashes, head-on crashes, and collisions with trees. And 50% of fatalities were including this of striking a tree as an event as part of that horizontal curve crash. Let's take a look at the Federal Highway Administration's lane departure trends and how those have changed over the years. So here you can see all fatality crashes and the roadway departure fatalities. So you're really close up there. Almost more than half of your fatalities are departure related. And you can see how they change pretty similarly, but not as drastically, which is a good trend. And then with that goal of getting closer to zero as we're looking forward into the future. So 46% from 2016 to 2018 were roadway departure related, And here you can see some of those other emphasis areas that are being focused. So we talked about the rollover, head-on, and tree fatalities, which are from the roadway departure crashes. And we are making progress. We are getting lower down with the fatalities and reducing those numbers. Something interesting here is seeing how the head-on are increasing and now currently surpassing the rollover fatalities, with those tree collisions being in the number 3 spot still. Let's look into those in a little bit more detail. So starting off with roadway departure that involves cross center line or cross median events causing that head-on collision. And this was to part of 27% of all roadway departure fatalities. And 85% of these were head-on roadway departure fatalities on undivided roadways, which is a major focus of the primary emphasis area to address those cross center line crashes. And we've also seen that undivided highways will continue to be a focus into the future. And the crash data also indicated a focus should be on high-speed roads with an emphasis on rural areas. But we don't want to ignore urban areas. Those are still a big issue, but rural is definitely a larger proportion. And then we got rollover fatalities. So this made up 26% of fatalities resulting from a roadway departure. And approximately 3/4 of these fatal crashes occurred in a rural area, and 72% had a posted speed limit at or above 50 miles per hour. These crashes have been reduced slightly in recent years, but they continue to be significantly overrepresented, especially on horizontal curves with that 43%. Some analysis found that rollovers are problematic in curves in both directions for the vehicles, although they do happen more frequently on the outside of the curve. And finally, we have collisions with tree, and this fatal crash type involved 19% of all roadway departure fatalities. This is a continued emphasis areas and focus on removing or addressing these roadside obstacles to maintain the clear zone is the main focus of this effort. Crash data indicates the need to address this both on high and medium speed roadways, both in rural and urban area, to meet the roadway departure goals. And trees are unique from other fixed objects because they're not necessarily installed. And sometimes if you don't maintain them, they will grow larger, they'll multiply over time, they'll get even closer to the roadway. So maintenance is definitely a big focus here. I do want to highlight, if you are interested in looking into a little bit more about the roadway departure strategic plan from the Federal Highway Administration, they have some great brochures online where you can read a little bit more about the systemic approach, some of these different countermeasures that can be applied that they've recommended through these focus areas, and get a little bit more detailed information about what I just touched on today. So with that, I want to take a little bit of a break and see if there are any questions, if anyone have anything they want to speak up to. Nathan, I don't know if there's been anything in the chat.
Oh, there is a question in the chat now. So it is earlier you mentioned that 93% of those accidents are driver error. Do you think with the increase of self-driving and smart cars on the road, this number will decrease? Do you imagine the impact will be beneficial or create new areas of concern on the roadway?
That's a great question. And I think the answer is yes to both of those. I know that research have shown an increased safety behavior with those autonomous vehicles and self-driving cars. Now, will there be different areas of concern that comes up for that? Probably, absolutely. With new technology, we do see areas and safety issues being answered and other problems arising, especially when you're combining self-driving vehicles with your regular human driving vehicles on the road and combining some of those behaviors. But generally, especially with lane departure crashes, the driver behavior of speeding, being distracted and sleepy. Those are definitely some areas that can be addressed with that autonomous driving function in the vehicle.
I agree. I definitely think it's going to help once the technology works better, works like it should, right? The failure rates are much lower, but it's still going to be a very long time, I think, before the adoption rate is there to see a significant impact. When you're looking at some of the trends and the data that Fanny presented, the usefulness of some of that is understanding, like like we hear about singular crashes, right? Like we see, hey, this one happened or that happened, or we're on a project and we pull it. But seeing the data, I think, really illustrates what's happening on a system perspective. I like to use, and we'll talk a little bit more about this at 10 o'clock with the bike ped module, but like pedestrian fatalities are one of those things that they are infrequent for the most part. Like when you look at the numbers, um, it's hard to predict where something's happening because it's just like any other fatality. You might have, 10,000, 20,000 movements at that one location before there ever becomes a problem. And that's where predicting where it's going to happen sometimes, or using some of these, a historical crash analysis can be difficult. Using those head-on crashes, for instance, aren't necessarily a flaw of the driver to that extent. But when we look at like comparing that with the driver error, a lot of times when you're seeing the head-on crashes from lane departure, it's from an overcorrection. So let's say a person goes off the road for whatever reason. We did a safety analysis recently on an off-system roadway, and there was a lot of over tracking. And what you get to is at night, it's hard to see the curve. There's not a lot of shoulder and the lanes are narrow. So, and it's not built to go at a slower speed. So once you combine all those factors, people are leaving the roadway. The thing is a lot of times people are still in control to some degree. So, but they panic and they overcorrect. And when they overcorrect, that's when they go across the lane and hit somebody else. In this particular one, like we were seeing a lot of run off the road crashes on the opposite side of the road. And what that is where people's going off the curve, they overcorrect, they lose control, and they end up on the inside of the curve. So, looking at shoulders, looking at better delineation, looking at rumble striping, looking at better signage. There's something called, and Fanny will talk about this later, something called like a sequential dynamic warning system, where it senses the car approaching and lets off a series of lights to the chevrons in the curve. So even though, even though it might be driver error, when we see these type of statistics of what's going on, it really does help to add the engineering countermeasures, because while it does happen, knowing what's going on helps us solve that problem. One interesting thing I helped Fanny, I was talking to Katie about this. I don't think we've mentioned it yet. Fanny did the analysis for our lane departure root cause analysis statewide. So she really is an expert on this. If you have questions, definitely ask her. And she'll go through how we solve those problems looking at the statistics. The statistics are important when we're looking at risk factors, right? Understanding, even if there aren't historical crashes necessarily, what risk factors are present to make sure that we never get those historical crashes. Any questions before she moves on? Take it away, Fanny.
All right. Yeah, and so with that great intro, Nathan, thank you. We're gonna move into more of a Florida focus and that root cause analysis that Nathan just mentioned, and I've been involved with the past 2.5 years from a lane departure perspective. So what is root cause analysis? So root cause analysis, it's a wide range of different approaches and tools and techniques that you can use to really understand the roots and the cause of the problems. So it's risk-based. So rather than historical crash analysis-based, it's an approach to identify those key risk factors for a specific emphasis area on those fatal and serious injury crashes. And we know, like Nathan mentioned, especially when it comes to ped and bike crashes, but even lane departure crashes, those fatal and serious injury crashes are rare and random in nature. Just because you had a vehicle run off the road on a specific 1 mile section of a road, and you put up guardrail there to make sure that no one else does it, and then you have a crash 1 mile up the road, and you're thinking, oh wow, why did that happen there and not where we put up the guardrail? That is just how crashes work. So this is just figuring out what are those risk factors and how do we, from a systemic implementation perspective or strategic criteria update perspective, how do we address these different emphasis areas? So we're focusing on lane departure today, but this is an approach that has been undertaken by the FDOT State Safety Office on these 3 emphasis areas. So both lane departure, ped and bike, and intersection, to create a proactive safety culture and make the strategic investment to achieve target zero. And what you might have heard about is the Pareto analysis, the 80-20 rule. And that's really the focus on this root cause analysis that, 20% of factors cause about 80% of issues. And that's what we want to focus on, those 20% of factors, and not on the 80% of factors that cause the 20% of issues. So using this principle, we can identify those factors that have the biggest impact and the biggest risk base for countermeasures to maximize the results. You heard about cheap, high impact countermeasures. That is definitely the focus of this area. So root cause analysis and the outcome that we're really looking for, especially from the State Safety Office perspective, is to identify the countermeasures and funding opportunities for state and local roads, and to be able to strategically inform future and ongoing safety initiatives and policy criteria updates, as well as engineering enforcement, education, and emergency service improvements. So I wanted to share a little bit about the data that we have on this effort, and this is looking at 2017 to 2021. So on Florida roadways, almost 33% of all fatalities and serious injury crashes are lane departure related. Put that into perspective, that is 15 serious injuries per day, 4 fatal crashes per day. So that's almost half of our room here to get a serious injury on every day on Florida roadways. So looking a little bit more at that lane departure crashes, so fixed object run off the road is the largest crash type within this emphasis area, 52%, and then followed by that head-on collision at 10%. The 15% of other crashes, we found that either being fixed object run off the road or head-on related, but those are the 2 major focus areas. You can also see a heat map here where those lane departure crashes are happening. You see kind of an equal split between the state roads and local roads, 54% on state roadways, and then how it's looking at an area type as well as that urban-rural splits. And then we have a breakdown by district as well. So you got your District 4 there, 14% of all lane departure crashes are happening in your districts. Digging into some of those key factors, so we got drivers, 69% make up our male drivers, 93% are Florida residents. And if we look at the environment from road surface conditions, 16% occur during wet pavements, and we got 21% during dark and unlit lighting conditions. And then looking at the state highway system, focus only right now, some of those risk factors that we identified are your 2 to 3 lane roadway, your 4 to 5 lane roadway, your C3C context class stands out, followed by C2. Combining that with your rural roads, your 2 to 3 lane roads is definitely one of our key risk factor groups. High-speed roads are up there, and then when you look at shoulder type, we got paved shoulder, and for median, that undivided makes up 22%. On top of that, you have the curb and vegetation median. So these are just kind of putting them a little bit separate. Our next step was to combine these to identify those key risk factor groups the FDOT State Safety Office have some great fact sheets available for these 3 emphasis areas, lane departure being one of them, where you can look a little bit more at what those risk factors are and how they relate to the different countermeasures that we are evaluating. But what this actually leading to, and I did want to highlight the statewide rumble strips initiative, which put $60 million invested in over 3,000 centerline miles of highway. And the risk factor that was identified was your rural 2-lane high-speed roadways. And those rumble strips had a benefit cost of 32 to 1 and are estimated to save 150 lives over the 7-year service life of those rumble strips. So a great initiative and a strategic implementation of statewide funding. And we are now looking at evaluating some more countermeasures to make some similar statewide implementations. So moving on to the Florida strategic approach and specifically our strategic plan. The Florida Strategic Highway Safety Plan was released in March of 2021, and there were emphasis areas determined after reviewing the data between 2015 and 2019. And those emphasis areas were categorized into 3 different groups: roadways, roadway users, and user behavior. So lane departure is one of those emphasis areas, and most fatal crashes that occurred are because of lane departure. 34% of crashes resulted in 42% of all deaths in Florida roadways between 2015 and 2019. So for lane departure strategies, there's a couple of different groups, and they include engineering, such as speed management. We talked about the rumble strips and curve delineation and high friction surface treatment. From an indication perspective, we talk about preventing speeding, minimizing distracted, drowsy, or impaired driving, and also increasing the amount of in-vehicle technologies. From an enforcement perspective, we want to identify key location and times to provide presence on the roads and focus on drivers who are speeding, distracted, or impaired. From an innovations perspective, we want to focus on ITS infrastructure to keep assistance with lane keeping. You've heard about blind spot detection, lane assist systems, and so on. Emergency response, want to keep access to emergency vehicle. We want to reduce response times. And from investments and policies, we want to integrate proven safety practices in projects at all levels on all of our roadways. And from insight into communities, reflect on those community needs and be land use specific. So I want to pause there when we've talked about some of our Florida specific initiatives before we're going to move on to state approach and countermeasures. So anyone have any questions in the chat?
Just a question was just posted in the chat. Is information from the root cause analysis consistent with the previous one, the first couple slides, which identified rural as the main concern for lane departure crashes? Does it mean even rural only contribute 35 crashes, its fatalities are higher?
So if we're talking about these statistics, so what you're seeing here on the right in the graphs, that is all lane departure crashes on Florida roadways between 2017 and 2021 crash data. And that is the 33% of all fatal and serious injury crashes. So these years are a little bit different from the data that's part of the Strategic Highway Safety Plan. That's different years. And then what are presented earlier today from the Federal Highway Administration and their initiative is even earlier data. So a little bit different numbers. Generally, what we've seen with these trends, even though we update with one new year, the trends generally stays the same. The proportion might change a little bit slightly, but generally we're seeing that overrepresentation and those risk factor remaining. All right. Any other questions, or we will move on? All right. So let's move into the staged approach and countermeasures. How are we going to fix all of these problems that we just showed with the data on a statewide level or a district level? So the objectives for roadway departure safety is number 1, to keep vehicles on the road, number 2, to allow for a safe recovery, and number 3, to minimize the severity of the crash. And how do we do that? So the first priority includes things as curb signing, pavement markings, friction treatment, and rumble strips. The second priority, we're looking at widening shoulder, providing shoulder, implementing safety edge, having a center line buffer, a clear zone, and traversable slopes. And finally, to minimize severity, we can include countermeasures such as breakaway devices and roadside or median barriers. What are the top lane departure crash problems? So from Florida, what I showed you previously, 52% of fatal and serious injury crashes are due to fixed object run off the roads. And some of the countermeasures that we focused on there are centerline and edgeline rumble strips, improving lighting, providing median and road sign guardrail, widen the shoulder by 4 feet, and from horizontal curves to provide chevron signs, high friction treatment, and then implementing safety edge and flatten your side slope. Our second emphasis area within the lane departure are those head-on crashes, which contributed to 10% of lane departure crashes. And countermeasures there, we look at WB guardrail in the median, providing a passing lane, improving lighting and visibility, post-mounted delineators, and centerline rumble strips. So let's begin with keepable vehicles on the roadway and those countermeasures. So these are all of the ones we'll go into a little bit more detail on, starting off with pavement friction. So pavement friction, or high friction surface treatments, is a polished and abrasion resistant aggregate which you put on top of existing concrete or asphalt surfaces, and you use an epoxy as a binder. And this really provides a sharp and angular top layer to your surface, which helps to keep vehicles on the road, especially during wet pavement conditions. It provides almost a 80% reduction for crashes during wet weather, and then run-off road crashes, you're looking at about 70% crash reduction, and overall a 50% reduction for all crash types. So high friction surface treatment can be installed by hand or using a machine. It can be mixed on site. And the biggest issue is conditioning of the existing pavement. But there's a lot of good specification and provided documents for that installation to get it to last for as long as possible. You have the high friction surface treatment guidance, and it will tell you where to use high friction surface treatment and where not to use it, and what pavement conditions to look for and how to apply that on your roadway. Then we have rumble strips and rumble stripes, and those can be both on your center line and your edge line. And here you can really see the impact of rumble strips and how they can improve visibilities. So there on the left is during the daytime, and on the right is during nighttime, and you really see that difference with the regular pavement on both sides of that rumble strip. The rumble strips provide a 28% crash reduction for run-off-the-road crashes. And then we have sinusoidal rumble strips, or mumble strips, that you might have heard about. So they are similar to our traditional rumble strips, but they have a wave pattern that are grounded into the pavement, which reduces the external noise that is produced, but still providing that awareness and the noise within the vehicle, just to kind of help a little bit with the surrounding environment, especially if you're within a residential area. To not produce as much noise when vehicle travels across them. And then we're looking at horizontal curve safety. So definitely safety is increased with those warning signs and horizontal curve guidance signs. These are all from the MUTCD signing, which helps you with guidance on what signs to implement where and how to implement them. We're also looking at larger than MUTCD signing, bigger oversight signs. You can double up with signs, provide beacons, provide LEDs in your sign panel or those retroreflective posts. And of course, we don't want to put up too much signs to be aware of sign density and not create too much confusion, but that is definitely something that can help to improve safety on a horizontal curve. There is a low-cost treatment for horizontal curve safety guidance that was released in 2016. They provide some guidance on site analysis and a systemic approach to horizontal curve safety. Some of the things they mentioned in there are pavement marking, signs, how do you improve safety with the pavement, and different roadside improvements, and what to think about when you have intersection in curves. Another thing to do is to help with controlling speed as people enter your horizontal curves. And speed feedback signs are one of those countermeasures. It can be installed upstream of that sensitive location to help with speed reductions. And it also helps alert drivers that there is something happening as they're approaching a curve. You can also set that speed feedback sign on flashing to kind of avoid the high score effect that people stop paying attention to those speed feedback signs. But it does have a crash reduction of 7% for 2-lane roads. Some other horizontal curve safety is your dynamic curve warning signs. They can be used as a caution beacon as someone heading into the curve. Sequential dynamic curve warning signs can be added as chevron signs throughout the curve, really help bring that visual awareness to the drivers, and it has a crash reduction of 44%. And another thing to help control speed are those optical speed bars, which can be used as you're heading into the curve. And they're placed with steady spacing or with decreasing spacing to give an illusion that drivers are driver faster than they actually are. This also helps with drivers feeling a little bit more inclused into the roadway and makes them hopefully slow down. And that is what safety analysis that was done by the Federal Highway Administration showed. You see that 85th percentile difference and the 50th percentile difference, how speed are reduced going into those horizontal curve from a before and after period. Another countermeasure are speed advisory markings in-lane pavement markings. Those are used as you're heading into the curve, which are supplemental to the curve warning signs. Can't do this one without the warning signs, but to help provide a little bit more awareness and get people to hopefully slow down. And then, of course, there are countermeasures for nighttime visibility, lane departure crashes, as I shared from the Florida statistics. There are a big percentage happening during nighttime, but especially during nighttime at unlit conditions. So things you can improve here are sign retroreflectivity, pavement markings, and roadway lighting. So that retroreflective or reflective signs really helps illuminating the signs better and bringing those lightings from the headlights of the vehicle back to the driver to increase visibility. So it is required by specification in Florida, and maintenance is definitely important to keep the retroreflective signs up to standard. And it can be augmented by adding strips to signposts, but what's important is to use the same color as the sign. And I'll say it again, maintenance is critical to keep these illuminated for as long as possible. here you can see those horizontal curve and how that truly is important during nighttime conditions, especially where you don't have roadway lighting. And then we have retroreflective striping. This is also required by specifications in Florida. And thermoplastic uses retroreflective glass beads. And similar here to the signs, maintenance is critical. There's a lot of times when I'm out in the field and we always see those retroreflective in pavement markings come loose. But here in the image, you truly see the importance of it, especially during wet weather conditions during nighttime, there on the left compared to the right. There are some guidance out there by the US DOT methods for maintaining pavement markings and retroreflectivity to get the greatest benefit of your implementations. And then we have lighting, roadway lighting, a crash reduction of almost 30% for all nighttime crashes when you implement new lighting on your roadways. There's also a difference between using the light-emitting diode light bulbs and the high-pressure sodium light bulbs. And this image here on the next slide truly shows the difference between those two types of light bulbs. The LED on the left is definitely illuminating a little bit more compared to on the right. So I wanted to take a little stop there before we move into how to provide for safe recovery. We've talked about countermeasures for keeping vehicles in the lane on the roadway and eliminating that lane departure crash. Any questions in the chat? No? All right. So let's move forward into providing for a safe recovery and those countermeasures. So we're going to talk about roadway shoulders and slopes, safety edge, and clear zones. And there is plenty of guidance out there for all of these countermeasures. They're also part of the Federal Highway Administration's proven safety countermeasures. So starting off with safety edge. So safety edge is just a way to finish off the edge of the pavement on the side of your road. Instead of having a complete drop off, it provides a 30-degree angle cross slope at the edge of the pavement. And this allows the vehicle to safely be able to recover back, especially if they have overcorrected. It will help them get back up on the road. And it also helps with the durability of the pavement and to reduce edge raveling and erosions and so on. So what makes Safety Edge really great is it's very low cost implementation. It only adds about 1% of extra asphalt to the roads. And the implementation of the Safety Edge includes an attachment that goes on the edge of the machinery to pave the roads. You don't need to buy an entire new machine. It's just that additional attachment to help level off the pavement at the edge of the roadway. So the Federal Highways Administration goal is to accelerate the use of Safety Edge across different states around the country and really provide this as a standard practice on all new and resurfacing pavement projects. So the key benefits of Safety Edge, we're seeing an 11% reduction in fatal and injury crashes, a 21% reduction in run-off-the-road crashes, and 19% reduction in head-on crashes. And that's from that overcorrection, helping people a little bit easier get back on the road. And just because it is such a low-cost countermeasures, we're seeing benefit cost analysis result between 700 and 1,500 to 1. So we are also seeing a reduction of fatal crashes by 34% by implementing a roadway shoulder. So this is where you don't have a shoulder before. Usually you'll see these conditions on your rural roadways. So providing that shoulder will hugely benefit the safety conditions on the road and provide a little bit more space for people to easily recover back onto their lane before they end up within the clear zone or into any obstacles that are on the side of the road. So you can see that depending on how much of a shoulder you add, your safety benefits will increase to the maximum that was evaluated as part of the HSM, the Highway Safety Manual. Adding an 8-foot shoulder, you can see a benefit of 11 to 42%, depending on that AEDT. And then we have clear zone. So your clear zone is an unobstructed traversable roadside area that allows the driver to stop safely or regain control of a vehicle that has left the roadway. So ideally, you don't want any objects in your clear zone. There are different clear zone requirements depending on your roadway, type of roadway, and the speed. Those are all part of the FDM to help you making those decisions. But providing a sufficient clear zone or even increasing that clear zone from 10 feet to 40 feet, you can see a safety benefit and a crash reduction of 32%. And something to keep in mind, depending on what type of roadway you have, if you have an undivided roadway, that clear zone do come across to the other side of the road. So you don't want to provide sufficient clear zone in both directions of travel. And for a multi-lane road with a divided roadway, also consider what's in your median for that clear zone. If you have a vegetative median, if you have any trees planted there or any utility poles and lines, make sure that they are not obstructing your clear zone. And here you can see some statistics from FDOT and the percentage of utility pole crashes for fatalities by site or vehicle characteristics, or really those risk factors. Urban areas are definitely a big one here, with 37% on horizontal curves, and 13% are caused by motorcycles. And then looking at collisions with trees in your clear zone, you have 62% on that rural area, especially your high-speed roads on those horizontal curves. So all those risk factors we've already touched on, but how that relates to what is in your clear zone. And then we have roadside slopes. So that slope can truly help people navigate back up onto the roadway. But if it is too steep, then they will have no chance of recovery. You can see two pictures there of just a different type of slopes. And if you go from a 1.3 to a 1.4 slope, you have about 18% crash reduction for lane departure crashes. And going from a 1.4 to a 1.6 has a 24% crash reduction for lane departure crashes. So really thinking about that critical, recoverable, and transferable slope. And, we want to end up there in the green. So really flattening that side slope can have a huge benefit. And combining that with adding a shoulder, adding safety edge, that's how we provide our roadways to be safer and provide for safe recovery. The FDM have really good criteria when it comes to roadside slope. How steep should that slope be? But then we can always go further than that and provide a less steep slope for safety benefits. So I want to stop right there for any questions about providing a safe recovery and those countermeasures. Are there anything in the chat? No? Any other questions? All right. So let's move on to tier 3, and that is reducing crash severity and those countermeasures. And we're going to talk about frangible obstructions. We're going to talk about different roadside barriers and median barriers, and then as well end treatments. So did want to highlight the approved product list, which you can find on FDOT's website, which provides some great resources and different materials you can use to create a safer roadway. And those are these frangible obstructions, for example. So this really shows you how those posts to your roadway signs, what happens during impact, to really avoid that sign going into the driver's side window and really hurting someone, and just being less of a hard impact for vehicle collisions. There's also different ways those can be fastened into the ground with a Wallman structure, and all of those are part of that products list that I shared earlier. And then there's also a different landscape types of vegetation that can be selected to be that fungible obstruction that still provides good coverage and looks beautiful, but do not increase the severity of a crash if a lane departure crash were to happen. So you have fountain grass, Indian hawthorn, Simpson stopper as a tree, and really just to make sure that if a vehicle hit that vegetation, it does not provide much of a collision. And then we got our roadside and median barrier. So you've probably heard about the high tension cable barrier. It will provide a 64% crash reduction for fatal crashes. And as you can see there, an increase for all crash types. And those numbers are a little bit biased, but if you put up a fixed object within your clear zone, you'll increase your fixed object crashes as the vehicle runs into that object, in this case, that high tension cable barrier. So that is why you're seeing an increase in crashes. But really that severity is being reduced as you make sure that vehicles don't cross over.
That's a good point, Fanny, because when you're looking at whether it's cable barrier or you're looking at guardrail or you're looking at jersey wall, that the whole those are like a least worst scenario, right? Because you're trying to keep people from leaving, you're trying to let them get back up on the roadway. This is this is essentially, if we don't stop you now, there's going to be a worse outcome. So in the case of cable barrier, if we don't stop you in the median, you're going into oncoming traffic. If you have jersey wall protecting a bridge pier, do you want to hit scrape the jersey wall or hit the attenuator, or do you want to hit the solid concrete bridge pier? It essentially, and that's how you make the decision, right? So you use cable barrier when you can. If you don't have enough space for cable barrier, then you use guardrail. If you don't have enough space for guardrail, then you use jersey wall. It's following down that process, and what it's doing at that point is saying that there is not hope that you're going to get yourself out of the mess that you're in. What we're trying to do at this point is just catch you as gently as we can, assuming that, I guess, concrete can catch you gently. But anyways, it is a least worst scenario. These are not, hey, you've left the roadway, we're going to put the stuff up to keep you on the roadway like a pinball machine. The idea is we're putting the stuff up to protect a hazard that is worse than just letting you go and recover naturally. Thank you, Fanny.
Thank you. So then we have W-beam guardrail, and also provides a great crash reduction at about 11% for fatal serious injury, but you're still seeing an increase in overall crashes because you're putting a fixed object within that clear zone. And then finally, that concrete barrier, or your fully rigid barrier type. There are a couple of other barriers that might not be mentioned as often. You have a low profile barrier, and as well as a temporary barrier type, where a type K concrete. You usually see these surrounding ongoing construction sites and projects. But what Nathan mentioned there's a lot of different things you want to consider when you decide what roadway barrier type you should be selecting for your roadway, for your project. That high tension cable barrier on top, followed by W-beam guardrail, and then a rigid barrier. The main thing you want to consider is that design criteria and the deflection space requirements. So a high tension cable barrier will deflect by 12 feet. A guardrail would deflect by 5, and then your concrete barrier doesn't deflect at all. You want to, depending on what object you're trying to avoid and how much right-of-way or clear zone you have, that will help you decide which cable barrier type. But to keep in mind, a cable barrier is cheaper followed by a concrete barrier more expensive. And what is that maintenance cost? You know, a cable barrier going to have a higher maintenance cost compared to a rigid barrier. But the main thing here is that vehicle impact severity. You'll have a less severity for that cable barrier, and then your rigid barrier are not going to exhibit any deflection under the impact, so the crash severity will likely be highest of all of those barrier options. One thing I do want to mention that there are different design vehicles for these cable barriers. This is all in the FDM if you want to take a closer look, but just a lot of different things to consider. The FDOT are recommending the high tension cable barrier as the best or the preferred barrier option for your continuous median barrier, as long as these design criteria are met. And finally, we have end treatments to those barriers, and just making sure that these are being provided. And why are those important, you might ask? And that is because improper end treatments might lead to catastrophic failures. And even those approved treatments can fail, ultimately decide if a collision with a guardrail and the risk of it failing is worse than what you're trying to protect. Someone getting impaled by a guardrail is not a great scenario. And of course, those end treatments, installing them is the first level, but then there needs to be proper maintenance to make sure that they uphold their quality. But these scenarios that you see in the images are definitely not what we want to accomplish when we put up guardrails to reduce the severity of the crashes. So, any questions there as we've gone through all of our different countermeasures that are available out there to help with lane departure safety? Anything in the chat?
There was a question in the chat about limitations for cable barrier applications, such as speed limits. Nathan did answer it, but if you want to go and add anything else.
So there aren't any specific requirements when it comes to the posted speed. The requirements that they have in the FDM is more focused on that deflection. And then there's a couple of different requirements depending on the slope that you are looking at, what cable barrier you should be using. They all come with it's more of a decision of those costs and maintenance requirements, and then what is the space you have available for that deflection.
We had a fatality in District 1 when I was still there, where someone went through the cable barrier, and a lot of the cable barrier that's on the system right now, I think, was installed under old standards when we were figuring it out. So when you see like cable barrier at the bottom of a ditch in the median, that's not always, to my understanding, that is not the correct way to be installed. And they were able to overtop it, and that's one of the reasons why. So in that issue, there's an upcry about cable barrier, about why we have cable barrier. We should just replace it all with guardrail. So we went and looked at I-75 and I-4 and pulled all the crashes where there's cable barrier, guardrail, or Jersey barrier hit and compared it. And the CMFs are very accurate. Regardless of what the crash rate is, there is much less severe crashes with cable barrier than guardrail, and guardrail is much less severe than Jersey barrier. It is really truly based on what you're trying to protect. It's like, bridges, you're going to have Jersey barrier on there because there is not any other space for you to move once you hit the side. The biggest issue other than design that is being seen with cable barrier is the maintenance. Most, not all of our the state's corridors were where cable barrier is being used, which is usually limited access, is under asset maintenance contracts, where there's essentially a performance spec given to a contractor and they have to maintain it. Now, if you think about those performance specs, and I want to say, correct me if I'm wrong, Katie, if you know, if there's someone else on the call, I want to say they're low bid. So the way you make money on it, obviously, is by providing as as few of services as you can. So if you have, for instance, a spec for grass cutting that says, you can't let it go over 12 inches, you're not going to cut grass until it's 12 inches. It's just not going to happen. So, and you see this with long line. There was an issue with long line. The way the MRP was done statewide changed a little bit. They got a little more strict with the MRP a few years ago. So some of the districts had issues with their long line no longer meeting MRP. And if you're not familiar with what that is like maintenance rating program, I think is what it stands for. And it's essentially they score all the state facilities to say this is how good your maintenance program is operating by saying, like with your long line, you're meeting this much retroreflectivity over this percentage of your facilities. So one of the issues where there was a performance contract on long line striping. So the way to make money on that once again is you would go out and stripe it as little as possible. And so you started seeing some of those issues. So with guardrail and with cable barrier, there's a performance spec that requires it to be fixed once it's hit. The challenge, though, is inventory. So whether it's an older system that has it's proprietary that it's a little more difficult to get parts for, there's not a desire to keep inventory on hand for that replacement when something gets hit. When you're dealing with guardrail, even if you can't replace it right away, the only thing that's out of commission is what was hit. The rest of the guardrail is still good. With cable barrier, the big challenge is once it gets hit, the entire section is down. So if you have a 1/4 mile section of guardrail, of cable barrier, all of it's down until you find the replacement. So it's something to where we may want to look at our performance specs and start specifying that there is a certain amount of that on hand. Or I know at least, like say, I used to work in the Bartow Operations Center, and we used to keep traffic cabinets, for instance, and signal heads. Like if something got slightly damaged, like where it was another project you're updating, like we would keep it in the warehouse, and then we would go back out and install something temporarily if something got destroyed while like the full fix was being done. So that's something to keep in mind. I still support it. It's when it's done right, it's extremely effective. You can see videos of it stopping like semis going 60 miles an hour, and it arrests it. The semi may tip, but like nobody's hurt. It's very, very effective, but there are some challenges that we can work to mitigate.
All right. So we are wrapping up Module 8. And just to do a quick recap, we have talked about a 3-part process to help with lane departure safety, keep vehicles in their lane, allow for easy recovery, and reduce those consequences and severity if they continue off the road. Some of those countermeasures are part of the roadway departure strategic plan are looking at overturn crash strategies, curb delineations, friction treatments and curves, edge line and shoulder rumble strips, safety edge, clear zones, traversable roadside slopes, and barriers. And to mitigate opposite direction crashes or head-on crashes, centerline rumble strips, friction treatments and curves, increase separation between opposing lanes, particularly in curves, and median barriers. And then roadside trees and shrub crash strategies. We're looking at edge line and shoulder rumble strips, curve delineations, friction treatments, clear zones, and barriers to shield from those fixed objects. So the key message from this education is that the only option that we have is zero fatalities. The only way this works is for every person in their job to focus on eliminating fatal and serious injury crashes. And these crashes are currently affecting thousands of people. Severe injuries stay with a person for the rest of their lives. If it's an amputation, mobility issues, severe scarring, lifelong pain, and so on. And this can affect any of us and any of the family or friends or loved ones. And we cannot emphasize this enough. 0 is the only number that matters. So with that, I wanted to say thank you to all of you who have participated in this Safety Academy training, Module 8 of lane departure safety. If you have any questions, feel free to put them in the chat or speak up, or you can always reach out to any of us, part of the Safety Academy group, at a later time, and we're happy to answer any of your questions.
So everybody knows the 3 ways to prevent lane departure, right? Who wants to name it? All right, short of any volunteers. Just recapping, Fanny did a phenomenal job. Just recapping, right? It's that safe system approach, like layers of defense. So we're keeping them in their lane, right? And we have the countermeasures to do that, whether it's high friction surface treatment, appropriate super elevation, make sure that we have drainage, a good cross slope, our shoulders aren't built up, the water can get off the roadway, rumble striping, better signs, right? So we're keeping them in the roadway. Once they leave the roadway, we're making sure they can get back. So whether that's a shoulder, whether that's good cross slopes, whether that is not putting obstructions in the way so they have time to get back on the roadway. Safety edge. So if there is a maintenance issue or washed out on the edge of pavement, they can still get back on without having to really fight the car. And then reducing consequences. So that's the frangibility of what we put out there, make sure breakaway stuff is done properly, make sure we're protecting our features, the features on that are adjacent to the roadway that we can't move out, right? So personal experience, last fall, we had some family friends that lost both of their children. They hydroplaned and ran into a concrete pole that Tico had on there, and both children died. When I look at it as an engineer, and I'm not going to put this in writing, but I'll say this here, the Tico pole was inside the clear zone and it was unprotected. It was raining at the time, and when I drove out there, the shoulders are built up. The water can't get off the road. While there is a good cross slope, the water can't get off the road. So that is an example of where, had everything there's multiple failure points, right? So at that point in time, the water couldn't get off the road. That was a failure point. The concrete pole was too close to the roadway. That was a failure point. The concrete pole wasn't protected. That was another failure point. So you see, like, where there's multiple things that had to happen in that sequence of events for that outcome to happen. So it is something that we do want to pay attention to. While that may have been the only time that happened in that specific location, we do know those risk factors were present and the system did fail them. So just keep it in mind when we're going through our day-to-day. Just because there aren't crashes today doesn't mean there's not going to be one tomorrow. We're trying to make a difference. There's a saying that anyone can build a bridge, but it takes an engineer to build a bridge that barely stands up. And the idea is, when you start looking at engineering, there's an efficiency and a dollar factor that usually comes into that. And that's fine when we're doing other stuff, right? But when we're doing safety, the efficiencies, while we'd like that BC, the efficiency really isn't necessarily there. Like, we're not trying to do the minimum amount and then check and see, like, an iterative approach to make sure that it worked. And, oh, like, someone else got hurt, so let's try a little bit more. Like, we want the redundancy of the safe system to make sure that if there is a failure, or when there is a failure, people walk away from it. All right. So if there's not any final questions, this meeting is going to end, if you remember, and then the next meeting will start at 10 o'clock. Great. Any final questions?
This was great. Thank you, guys. And I will say, I think the ped bike one is lengthy, right? So we want to start like right on time for that one.
Yes.
So if you all can try to be there. All right.
All right, guys. Have a good day. See you soon.
Thank you.